Okay, so lots of different ways to do this. A lot of folks like to plug in numbers. So if you do that, let's say you plug in t is 0 and the d value should be 15. So if I plug in t is 0 right there, 0 plus 15 is 15, this one works. 0 plus 12 is not right. 0 plus 15 works. 0 plus 3 is not right. And 0 is definitely not right. You don't get 15. So if you plug in just the first point, a lot of folks are tempted to choose that first answer. You need to plug in at least one more point if you do it this way. So 1 plus 15 is 16. That one can't be it. It's got to be this one. Just to double check, 3 times 1 is 3, plus 15 is 18. It works on both those. It's going to work on the rest at that point. Some folks will look at this very much like mathematically. Right? So they just see the y-intercept is 15. They think about, y equals mx plus b. So they see that the y value is definitely 15. So I think these answers go away really quickly. They see the pattern, x is increasing by 1. So the denominator is increasing by 1 for slope. Y value is increasing by 3. It's going up by 3. It's got to be a slope of 3. It's got to be 8. Another way to do this is to graph this in your calculator. So you could get out your graphing calculator. You'd have to type in x, so 3x plus 15. And you could look at the table. Control T is the table, and you can see that 0, 15, 118, 221. Very quickly, you can see that all those values work, and you've got it. This one, you could set up an equation. We'll do that in a minute. Let's just kind of do this. So when I try this kind of problem, I like to plug in the middle answer first. So let's pretend Jane is 35. If this is true, that the sum of their ages is 44, if Jane is 35, that means that her daughter must be 9 because they add up to 44. So if that's true, what's the ratio of the daughter's age to her age, or her age to her daughter? So 35 divided by 9, is that equal to 9 over 2? So let's get our calculator out and try that. I just want you to see how this works if you do it this way. So 35 divided by 9. I want a decimal, so I'm going to get it like that. And 9 divided by 2, 9 divided by 2 is 4.5. So this is not big enough. They're definitely not equal. I know that one's wrong. But I need a bigger ratio. I need it to be 4.5, and it's not. So I need, I think I need Jane to be older. So I need this number to be bigger. So I don't think these are going to be one of the answers. And 22 would be really weird because that means her daughter would be 22, which doesn't make sense. So let's just try the wrong answer on purpose here. So let's try 40. So 40 over, I guess the daughter would have to be 4 because it adds up to 44. Is that equal to 9 over 2? Well, I know 40 over 4 is equal to 10, which is not 4.5. So that's too big. So that one doesn't work. At this point, you're in such a hurry on this test, I would circle D and move on. We could test it and make sure we're right, but that'd be the way to go. Another way to do this is to set up an equation. So you could say, x over 44 minus x equals 9 over 2. So x being the Jane's age there. And then you could just solve for x, right? Cross multiply, so you get 2x equals whatever, 9 times 44. 9 times 44. So 396 minus 9x. So 11x equals 396. Now let's see, 396 divided by 11 is 36. So it does work. Wasn't sure it was going to work out, but it did. And so that'd be the algebraic, or one of the algebraic ways of doing it. Some people set up equations like 2x plus 9x. Wait, let me see. Yeah, 2x plus 9x equals 44. They'll find out what x is, plug it back in here to get Jane's age, plug it back in here to get the daughter's age. That would work as well. So there's lots of different ways of thinking about this one. Kind of interesting puzzle problem there for sure. This one way of doing this is to cross multiply and solve like we just did, and you could do that. Another way is to simplify this. So the right-hand side, I would say, is what? That 7 goes into both, so that would be 7 times 5, so 5, 6. So we get 10 over 10 plus x. I like to use the structure of the problem here. So 5, 6, can you see the relationship? If you multiply 5 times 2, you get 10. So 6 times 2, this number here should be 12, the total number. So 10 plus what is 12? 10 plus 2 is 12. And you've got different ways of going about that problem, but that's one way of seeing it. Given the functions, what is that? So hopefully you know how to do g of negative 3. That means you're plugging in negative 3 right there. So that would be negative 3 squared, which is 9, minus 4, which is 5. So that guy is 5, so it'd be f of 5. So now you're plugging 5 in there for x, so 2 times 5 is 2 times 5 plus 1 is 11, and you get your answer. It's a really cool way to do this in your calculator if you haven't seen this before. So you get the very first command in your calculator, if you have menu 1 is defined. It's really cool. So I'm going to say f of x equals 2x plus 1. And percentage. And I'm going to define, so menu 1, g of x equals x squared, x squared minus 4. And I'm going to type in f of g of negative 3. And it does it for me, which is kind of amazing. So even on the ACT calculator, the CAST, non-CAST version, that's going to work just fine. Okay, this one, probably I would think about, it's kind of a classic algebra problem. Maybe set up a system of equations. So maybe 3x plus 4y equals 25. And then 1x plus 2y equals 11. So we have a system of equations. As long as you know that the x is flannel and the y is calico. And then you would just solve that. And so rather than taking the time, kind of like we did, so on the ACT calculator, there's one less option. So when you go to menu algebra, solve systems, you only can solve a linear system. So will be the only option available. That is a linear system, so it will solve this, no problem. You would just type in 3x plus 4y is 25, and then x plus 2y equals 11. And you get the answer is x is 3 and y is 4, which is calico. And they asked about calico, so it'd be 4. If you know your exponent rules, this is super easy. It's just the reciprocal power. So a to the negative 2 equals 1 over a squared, right? So it's pretty fast, pretty easy. If you don't know that, here's kind of a workaround. So you can actually, in your calculator, store a value for a. So I'm going to say a equals 3. I'm going to use the define command, menu 1. So a equals 3. I think that'll work. That does. Okay, so a is 3. So now I'm going to type in a to the power of negative 2. It says 1/9. If I type in the answer choice that might match that, 1 over a squared, we think it should match it, right? It is also equal to 1/9. So you can see that those are equal. If you typed in one of the other ones, like negative a squared, it's not equal to 1/9. And so you could just keep typing them in. It's kind of a long way of going about it, but essentially letting your calculator do the work by plugging a value in. I like you to know that backup plan, even though you might not need it here. Okay, let's try this one. So this one, if you know your algebra, this is not too bad. We need a common denominator. So here we're going to, let me just get a little smaller pen here. So we get this one, you multiply by 5. 5x would be our common denominator. So you're multiplying by 5 over 5. Here you multiply by x over x. So you get 4x plus 35 up top, and 5x would be your common denominator. You're adding those fractions, so 5x, it's got to be this one, right? The other way of doing this is kind of like I was just mentioning. You could plug a value in for x. My favorite value to plug in is 3. So you store a value for x, and you type it in. So let me just show you a different way on your Inspire to plug a value in. So if you want to, so if I want to type in 4/5, so 4/5 plus 7, whoops, control divide, 7 over x I'm going to put the vertical bar there. So control equals, we use that in our project. And so we're going to say x equals 3, my favorite number to plug in. It's going to give me some answer here, right? So now if I plugged in that same value of 3 to one of the answers over there, so if I type in 4x plus 5 over 5x, vertical bar, control equals, x equals 3, you should get, whoops, 4/5 plus 7 over x. Doing anything wrong. So it helps if you type the answer right. So plus 35 should be 47 or 50. Now you can see it matches. And it should because it's equal. This sign right here is an equal sign right there. So because it's equal right there, they have to be equivalent. So we're letting our calculator do the work. I'd like you to know that backup plan. If you're stuck, the algebra doesn't come to you, you could always plug in a number and it kind of works. This is a good example. So some of you, I would say a lot of you don't know how to do this problem. So let's try our backup method, right? So let's plug in a value for x. What's my favorite value to plug in? I'd say it's 3. Make sure your calculator is set to degree mode in the top right-hand corner. If it's not, click that and it should change to degree mode. So if I type in sine of x or sine, so let's do x, store x is 3, right? So then let's do a sine, you can hit the trig key if you wanted to, sine of x is, oh, by the way, on your handheld, on the ACT calculator, it'll always give the decimal. It won't give you that sine of 3 business. So it'll give you 0.052. So I want my answer to be not equal to 0.052. So let's see what happens when we type in some of these other answers. So negative, whoops, negative, if I hit the negative key, there we go, negative sine of negative x. And I should probably hit that. Same exact number. I want it to be not equal. That's not it. So if I type in sine of negative x and hit Control Enter, if I remember, that's negative. That's not the same. That's got to be it. And so all of those are equal to that one. If you didn't do that, you could maybe figure it out by drawing it out. You know, like if this is x right here, this would be 90 minus x. If that makes sense to you, this is not too bad of a problem. Let's just call this A, B, and C. So the sine would be equal to what? A over C. The negative, ooh, I don't know. See, with the negatives, we don't know how to do this we need unit circle trigonometry, which you guys haven't learned yet. So I could show you how to do this with the unit circle, but I'm going to not show you that because you're not ready for it. You just haven't learned that yet. So our backup plan is just to plug in a value when you're stuck. And this would be a case where you haven't learned this yet, unless you've learned about unit circle trigonometry, which for our school is definitely in pre-cal. This one we have learned. So we have learned quite a bit of this. And so if you see, like, there's a hole at 3, so I know there's a discontinuity at 3, so I'm like maybe one of those. It looks like there's a vertical asymptote at -1, so I think it's probably one of those. It's got to be J. Those are both points of discontinuity. They're not in the domain. I hope you saw this. I don't know if your gut told you to do this, but I'm hoping you saw that as an Algebra 2 student and go, man, you know what? I got to factor that guy here. So that'd be 3 and 1, -3 plus 1. So x equals -1, x equals 3. Oh, that's the answers, right? That's another way to get it. So another way, you could actually graph it in your calculator. I know that sounds crazy. You're like, there's a graph right there. But the benefit of graphing your calculator, you have access to all these tools in your calculator that really could help you. Whoops, x squared minus 2x minus 3. So if you graph it, if you use the trace key, here's what I mean. So menu 5.1, you can type in a value like -1, and it shows you the asymptote. It says it's undefined at -1. If you type in 3, it shows you asymptote kind of looking thing, but it says it's undefined. It doesn't show the whole, but it says it's undefined. And those are the two values where the graph is undefined. It's not part of the domain. If I typed in 4, that's part of the domain. Type in 1, that's part of the domain, right? Everything else is except for those two values. Okay, this one requires a little bit of math. So if you plug that 7 in right there, so you get 7 equals natural log of x minus 2 plus 3. So we get 4 equals natural log of x minus 2. If you remember your exponent, you can put this in exponent form. So using math, this would be e to the 4th equals x minus 2. The last step would be to add 2 to both sides to solve it for x. If you added 2 and added 2, you get e to the 4th plus 2, which is that answer. If you want to just use your calculator to plug that in, you can do that on a calculator screen, right? So you can actually type in, natural log x minus 2 plus 3, put the vertical bar. We're gonna say x equals e to the 4th. I think there's the e to the something key, e to the 4th plus 2. When I do that, it's equal to 7, which is what I want it to be equal to. So you could, again, just kind of, the nice thing about that, you can store different values. So I like just changing it like this. I could just plug in 6. Oh, that doesn't work, right, when I plug in 6. But you can plug in different values there pretty quickly with the copy and paste feature by mousing up and pressing enter in case you didn't catch that. Okay, this one, so we could kind of FOIL that out, right? Wow, that's like a lot. It's a little bit of, it's a lot here. So if you remember how to do this kind of thing, we're actually multiplying x minus 3i 3 times. Let's do these two. So this will give you x squared minus 3ix minus 3ix is minus 6ix. And then last times last would be positive 9i squared. That should simplify a little bit. X squared minus 6ix. That would be minus 9 if you followed that. I squared is equal to negative 1. And then we've got to FOIL these together. I sometimes do this. I'll check first times first is x cubed. All of them are x cubed. Last times last would be positive 27i. That one's gone. That one's gone. I think that one's gone because I know this is going to have more terms than just 2 terms there. So really debating between these two. So now I look at this negative 9x squared and negative 3x squared. Which one would it need to be? So if I multiply x squared times this number, I would get negative 3ix squared. If I multiply this one times the x, I would get minus 6ix squared. That's going to be negative 9. It's got to be f at that point. Love this problem. It's really good. If the solution's at 6, x equals 6, I know the factor has to be x minus 6. It can't be one of these guys. If this is negative 4, it can't be x minus 4. It has to be x plus 4. The end behavior is up, up. So that means it must be like x squared or x to the 4th. It must be an even degree problem if it's up, up. This one would be x to the 3rd, which is odd. That's down, up. It's not going to be that one. It's going to be one of these. These are both x to the 6th, which it could be. So it's going to be up, up in that case. So then you think about this idea of multiplicity. Do you see how this graph kind of bounces at that axis when it hits the x-axis at 0? So my thought is it's got to have an x squared, an even exponent there. It can't be odd. It's got to be d at that point. Love this. We just had some probability stuff. First 3 digits are 555. That's like 111, right? We're not making a choice on those digits. But the next digits are going to be 10, 10, 10, and 10. So 10 to the 4th would be the answer here. Classic question here. So 5 distinct numbers, that means different numbers. I'm just going to choose 5 numbers, 1, 3, 5, 7, and 9. When you pick even number, like symmetric numbers like that, this is not only the median, the middle number, it's also the mean. Only when these numbers are symmetric. Do you see how 1, 3, 5, 7, 9, very symmetric. I choose easy numbers like that, just makes it easier. That's set A. If you look at set B, all those numbers are the same, it says, but this one's going to be bigger, make it maybe 2. So that one's 2. How does that change things? The median is still the same. The median stays the same. The mean is going to be a little bit bigger. So I know the mean gets bigger. Median is the same, so it's not one of those. Mode is the most common. It doesn't have a mode. It's all different numbers, so it can't be the mode. It's got to be the mean. And last problem, classic problem. I would, again, kind of like we did on the other problem, try testing the middle answer first. It's a great way to go. So 16 red marbles out of 42. So right now, 16 out of 42. So let's just type that in our calculator, see what that is to start with. So if I do 16 divided by 42, that's 0.38. I want, this is going to be equal to 0.6 here. So I want 60%. So I don't have 60% right now. I want that. So in my numerator, I'm 16 plus 37. I'm adding 37 red marbles, but that affects the denominator as well. A lot of students have trouble with this, but you added 37 marbles, so both are changing by that amount. That gives me 67%. That's too many. So I added too many red marbles, so I know those are gone. I'm going to try 18 next. So by using this, I can also copy and paste, right? And I can change that to 18. And it gives me 56. That's too low. So at that point, it's got to be 23. Move on. You can adjust it if you needed to, but that's the end of the screencast. There will be a quiz on the ACT. Very similar to this one coming up soon.